Hello, everyone. Have you ever thought about how a chemist in India can read a paper from, say, Japan and know exactly what chemical compound they're talking about? How do they all speak the same language? Well, that's exactly what we're going to talk about today. It's called nomenclature, and it's basically the universal language of chemistry. It makes sure everyone everywhere is on the same page. So, let's start.
And why is this so important? Well, just think about this. In the world of medicine, in pharmaceutical companies, a small mistake in the name, it's not just a typo. It could mean a patent worth crores becomes invalid. Or worse, it could mean the wrong chemical gets made, something that could be very dangerous. So you see, the stakes are very, very high.
So this brings us to the main question. Why do we bother with all these rules? Why do your teachers make you learn this? It's really for three simple reasons: clarity, safety, and, well, global communication. It's so that there's no confusion, everyone is safe, and a chemist in India and a chemist in Japan are 100% talking about the same thing.
Okay, so first things first, let's look at why getting these names exactly right is so important. It's not just about being neat and tidy, it's something absolutely fundamental.
Okay, now for your exams. Here is the definition you should write. Nomenclature is the systematic naming of compounds using what we call IUPAC rules. And for the haloalkanes we're studying, the halogen, the chloro, bromo, iota part, it's always named as a prefix on the main hydrocarbon chain. Think of it like this. We're giving every single molecule its own unique, official name, a name that no one can ever get confused about. All right, let's see why this clarity is so important. A very common mistake I see students make is this. They see a 3-carbon chain, a propane chain, with a bromine attached, and they just call it bromopropane. But tell me, is that name good enough? Is it 100% clear? No, right? Because where is the bromine? Is it on the first carbon? Or is it on the middle carbon? We don't know. The name is ambiguous, it's confusing, and that's why the position number is so crucial. It's not optional, okay? It is the most important part of the name. When you say 2-bromopropane, you're giving a very specific instruction. You're saying the bromine is on the second carbon of the propane chain. Now there is zero confusion. That is the correct name. Okay, I know what you might be thinking. All these rules can feel a bit much. So, to make it really simple, let's use an analogy. Let's forget chemistry for a second and think about something we all use, a simple postal address. And you'll see how well this works. Look at this. The position number, that 2- part, is like the house number. It tells you the exact location. The halogen, the bromo part, that's like the name of the street. And the parent chain, the propane, that's like the town name. So when you say 2-bromopropane, it's exactly like writing an address. House number 2 on Bromo Street in Propane Town. See? A complete, unique address for that molecule. But why did we need such a system in the first place? Well, you have to understand, before these IUPAC rules, chemistry was a bit of a mess. People in different places used different common names for the same chemical. It was very chaotic. So this whole system was created to solve that confusion, to create one single, clear language for everyone in the world so that if you order a chemical or try to repeat an experiment, you know you're getting the exact right molecule every single time. Okay, so the address analogy is good, but how do we actually use it to name a compound? Let's get practical. In this next part, I'll show you a simple step-by-step method to write the correct address for any haloalkane. And to make it even easier, let's build a picture in our minds. Just imagine the carbon chain is a long street with houses lined up in a row, and each house has a number. Now the halogen atom, whether it's bromine, chlorine, whatever, it's like a colorful flag that you've put up on one of the houses. So with this picture in mind, naming is just a simple 4-step job. Ready? Step 1, identify the flag. What color is it? Is it a bromo flag or a chloro flag? Step 2, find the house number. Which carbon is the flag on? And a very important rule here, you always number the street so that the flag gets the lowest possible house number, okay? Step 3, name the street itself. How many houses or carbons are there in the longest continuous chain? That gives you the parent name, like propane or butane. And finally, step 4, write the full address. Just put all the pieces together in the right order. Simple. Okay, now for something really interesting. You might think, what's the big deal if I write 1- instead of 2-? It's just a small number, right? But in chemistry, that one tiny change in the name, it creates a completely different reality inside the lab. Let me show you what I mean. Look here, we have 1-bromopropane and 2-bromopropane. In a bottle, they might both look like the same clear liquid, but their chemical addresses are different, and that changes everything about them. In 1-bromopropane, the bromine is at house number 1, which is a primary carbon. This makes it react in a very specific way through something called an SN2 reaction. But in 2-bromopropane, the bromine is at house number 2, a secondary carbon. This means it can react in 2 different ways, SN1 and SN2. Now, don't worry about the details of SN1 and SN2 right now. The main point is that small change in the number leads to completely different chemical behavior. They're 2 totally different compounds.
So what does this tell us? It tells us something very powerful. An IUPAC name is not just a random label. No, it's actually a code. That tiny number, the 1 or the 2, it encodes the actual physical structure of the molecule. And that structure is what decides all its properties and how it will behave in a reaction.
All right, we've covered a lot. So let's quickly recap the most important points. Think of this as your toolkit for handling any nomenclature question that comes your way.
So, what are the key takeaways? First, nomenclature is just a universal address system for molecules. Simple. Second, that position number, it's the most crucial part of the address. Don't ever forget it. Third, always use that mental picture, a street of numbered houses with a colored flag. It makes it so much easier. And fourth, and most importantly, a different address means a different compound with totally different properties. So please, just remember these things: the address system idea, the picture of houses and flags, and the fact that a different name means a different chemical. If you can keep these in mind, I promise you, this topic will feel so much easier when you see it in the exam. So I'll leave you with this question. What's in a name? Well, in chemistry, a name is everything. It's the key that tells you the molecule's structure, its properties, its entire story. If you can master this language, you can master the chemistry.